The following, number 6, the following diagram shows a graph of f of x is equal to x over x squared plus 1 from 0 to 4 in the line x equals 4. Let R be the region enclosed by the graph of f, their x-axis, and the line x equals 4. Find the area of R. Of course, the R, they showed you a picture, so R is this highlighted region here. Okay, and you want to find the area on between the curve x equals 4 and the x-axis, so this part here. And this would be a simple integral question from 0 to 4 x over x squared plus 1 dx. Okay, so I saw a lot of mistakes here where you set up the integral correctly, but you take the different derivative of this integrand. So that was maybe the most common mistake here. Here you can do this by inspection, or you can do this by u substitution. So by inspection, you can see that, okay, I'm gonna have, this is 1 over something, and the derivative of the bottom here is 2x, and I just need to get rid of the 2, so multiply by 1/2 maybe. Maybe that might be your thought process, and you can get there, and you want to evaluate this from 0 to 4. Okay, if you didn't see that right away, you can still do it using u substitution. So if I didn't see this integral right away, I can say, okay, well, I'm going to use u substitution. Derivative of the bottom denominator is 2x, and it's a constant multiple away from what's on top. So I can do that. I can do u substitution. Let u equals to x squared plus 1, then du is going to be 2x dx. And I have x dx here, but I don't have a 2, so I'm going to say 1/2, divide both sides by 2. Okay, so here is 1/2 du. Instead of x dx, I'm going to put 1/2 du. And x squared plus 1 is u. So I can rewrite that integral as 1/2, maybe put it outside, 1 over u du. Okay, replacing x dx with 1/2 du, and denominator x squared plus 1, I'm putting u. So this integral became integral in terms of u instead of x, and it looks a lot simpler. And I know the integral of 1 over u is ln of u, so I can say this is 1/2 natural log of u. Here's a plus c because it's a definite indefinite integral. And then here, since I've taken the integral of this function, I can replace the u with the original function x squared plus 1. So I can write 1/2 ln of x squared plus 1. And since I'm going back to x, I can put the endpoints there from 0 to 4. And you end up getting to the same place. Right? Now, you don't stop there. Going and actually find the area. And what would we do? We evaluate this integral from 4 and 0. So 1/2 ln of 4 squared plus 1 minus 1/2 ln of 0 squared plus 1. Alright, that's natural log of 1, and any log of 1 is 0, so this right side is all gone. So that's equal to 1/2 ln of 17, and you can write maybe natural log of square root of 17. Anything equivalent to the bottom row here would be okay.